Good evening, folks, and welcome to the Advent of Code C++ live stream. My name is Craig, and tonight, as every night during Advent of Code, we'll be working through solutions to the puzzles in C++. I want to thank you for watching. Thank you for tuning in. If you're watching the live stream on Twitch, you can head to the channel description, and there you'll find links to my YouTube channel where we post replays of these streams in case you miss a day, and the GitHub repo where I upload the source code for all the puzzle solutions that we work on. On the other hand, if you're watching on YouTube, just check the video description down there. You're going to see a link to the Twitch channel for the live streams, plus once again that link to the GitHub repo where we have all of the code that we write. So, the last couple of days on Advent of Code, we started getting into, some actually, kind of tricky, algorithmically interesting puzzles. We're getting into things where, we have to take a little more time to think about what we're doing. And I think that, the puzzles are starting to get pretty fun now. This is exciting. Of course, the puzzles are also tending to get a little more difficult as they do as Advent of Code goes on. Every year that I do this, I find that there's usually at least one puzzle that's really kind of a stumper for me, and I maybe have to step away from for a while and come back and work on again. So you never know when we'll run into one of those. We'll see. But I will do my best to think through what I can on these live streams for you. So we have just about 3 minutes to go until tonight's puzzles unlock. I have already set up just the basic skeleton of a solution program here for part one. We have a C++ program that doesn't do anything, just your normal main function, returns 0 here. I have included the check and IO libraries that I've pre-written that you can find in the GitHub repository, because we tend to use those every night just to perform assertions and safety checks, and to read in the files that we get for our puzzle input. Since yesterday's stream, I did make some updates and just a little bit of cleanup for my part 2 solution from last night. For one thing, I used this type alias chords instead of pair int to make things a little cleaner. I introduced this helper method, adjacent cells, so that wherever we need to find cells that are adjacent to something, either to find a low point or to calculate, out the expanding basin, then we can just use that instead of trying to duplicate logic in different places. I rewrote basin size so that it is a little bit cleaner with the way that it inserts stuff into the basin here. And then this top 3 basin size product, instead of calculating all the basin sizes and then doing a top end sort to sort just, like the top 3 in the beginning, this I only keep 3. I only keep the top 3 that we've seen so far, replacing them as we go along, and then finally using this call to accumulate with standard multiplies to multiply them all together and get our final answer. So that is so I made some modifications, just get a somewhat cleaned up, nicer solution since yesterday. But you can see the full history of that in the GitHub repo. You can see the different commits of me kind of tidying up the solution. But turning our attention back to today, day 10, we have just about a little over half a minute until day 10's puzzles unlock. You can see we're getting more and more of this picture here that we're unlocking of, ASCII art under the sea as our submarine delves deeper and deeper in the search for the lost sleigh keys. Just a few seconds now. And away we go. Syntax scoring. You ask the submarine to turn the best route out of the deep sea cave, but it replies, okay. Syntax error, navigation subsystem online, all of them. All of them, damages worse than you thought. So we bring up a copy of the navigation subsystem. Okay. so we have to match different kinds of parentheses. So curvy boys, square boys, squiggly boys, and pointy boys. As I was recently educated how to pronounce all the different kinds of bracket in C++. Chunks contain 0 or more other chunks. Adjacent chunks not separated by any delimiter. One chunk stop, next chunk, if any, can immediately start. Okay. Oh my gosh, you guys. Well, no, I can't tell you where I've seen a problem like this before, unfortunately, but you might be able to guess. Some lines are incomplete, but others are corrupted. A corrupted line is one where a chunk closes with the wrong character. Okay. So aren't corrupted, just incomplete. You can ignore these lines for now. Rank 5 are corrupted. Stop at the first incorrect closing character on each corrupted line. Did you know that syntax checkers actually have contests so you can get a high score for syntax errors in a file? It's true. To calculate the syntax error score for a line, click the first illegal character on the line and look it up in the following table. In the above example, an illegal right paren was found twice. An illegal... okay, so we have to count up all the different ways that it's illegal. So we have this whole navigation subsystem. Okay. All right. So I think we can do this pretty easily with a stack, I think, just to keep track of what's open and what's closed in our system and make sure that it's balanced. So let's go ahead and, first of all, let's get our puzzle input. I'm just going to go ahead and save that as day10.txt. And I'm going to see what that looks like. Okay. You know, open that in Nano without word wrapping just to see how many. Okay, so quite a few lines of that. So we will go ahead and read in our input. Read lines from file, use argv1 to get the first line of the program. And then we can just, I mean, I'm going to go ahead and put this in a class because, well, no, I'll just do a function for right now. So we'll just go ahead and say, no, it doesn't need to be as. We'll just use optional int error score on a string view, which is the line. And so if the line is either valid or incomplete, we will return null opt, meaning, you know, there's nothing here. But if it's an error, we will go ahead and report the score. So we'll say we'll have a stack. Well, here I'm going to include the stack header. And so this stack is going to be a stack of characters for like the opening characters that we've seen. And then as we see closing characters, we will check to make sure that they match the top of the stack and pop it. So we'll call that parens, you know, for all the different kind of brackets, all the different kinds of parentheses. And we'll say for char c in line We're going to switch on that character. So for all the open parens, we are just going to push something new onto the stack. So that's curvy boy, square boy, squiggly boy, and pointy boy. So for all those cases, we just do parens.push C and break out of that. Now, in the cases where we have something that is closing, so we'll say if parens.top is equal to the opening curvy boy, then this is correct, and we will just keep on going. So in this case, we will say parens.pop and break. Otherwise, we have an incorrect close, and we will return 3, which is the number of points that we are supposed to assign to that. And then we are going to do, I'm actually going to copy and paste a little bit because we're going to do very similar things for the other 3 types of closing characters. And here the score is 57. For the squiggly boys, the score is 1197. And for the pointy boys, the score is 25,137. And then the default case is, we're going to go ahead and check fail there because that's an invalid character. That's a syntax error of a different kind. So right now we are supposed to just ignore incomplete lines. So we don't really care if the stack is. Oh, actually, we should look at unclosed things too. I'm realizing. So we'll say. Because obviously, something that closes but was never opened is going to be invalid as well. So actually, I might switch this logic around here and say if parens.empty or parens.top does not equal that, then we return 3. Else, we can say parens.pop and break. Yeah. I like that a little bit better, so I'm just going to go ahead and do the copy and pasting and rewrite these conditions as well. Because, yeah, I think that we do need to handle the case when the stack is empty. So, change the opening characters that we are looking for, and change the scores 57, 1179, and 25,137. Okay. So if we get down here, again, we don't care if for now at least, we don't care if that stack is empty or not. At this point, we're just going to return null opt, which means nothing for that optional int. It's not actually an illegal character. So So to total all these up, we will just loop over all the lines. We will say Actually, we'll just say error score plus equals error, the error score function applied to that line dot value or 0. So what that value or is going to do for standard optional is if the optional holds a value that's one of these, it will return that value. But if it's unengaged, if it's null opt, then it will just report as 0, and so it won't contribute to the overall error score. So then we can print out the error score with cout. And I believe that is our solution. So need to include the abcel strings library for the abcel version of string view. So we'll just take this, modify it a little bit. Let's go ahead and now run our part 1 program on our day 10 input and see what it gives us. Okay. That was not correct. Oh yeah, you need to do double dash to provide the arguments there. That's what we did. Okay, so our score is 370,137. Let's see if that is correct. Not the right answer. Okay. I'm going to take this sample input and use it as a test input and just see what it gives us, and maybe that'll give us a little more insight. Okay, so it says 26,379. It should be 26,397. Did I just type something in wrong? Yep, 1197 here instead of 1179. I just typed it wrong. Had a moment of transposition of characters there, but we run it again on test input. It gives the right input. Let's just run it again on day10.txt. 370,407. Let's see if that is correct now. Yep. Okay. Typo, that's all it was. Now discard the corrupted lines. The remaining lines are incomplete. Incomplete lines don't have any incorrect characters. Instead, they're missing some closing characters at the end of the line. To repair the navigation subsystem, you need to figure out the sequence of closing characters that complete all open chunks in the line. Well, conveniently, that is just going to be unwinding our stack. Yeah, that this is going to be quite easy. Yeah. So I'm going to, so I see the scoring rules here. The score is determined by considering the completion string character by character. Start with the score 0, then for each character, multiply the total score by 5, and then increase the total score by the point value given for the character of the poly table. So we start with 0, and then, yeah, as we unwind our stack, all complete totals are not a bunch of where's found by sorting all the scores and then taking the middle score. There will always be an odd number to consider. Okay. We can do this. Easy peasy. So first thing I'm going to do is make a commit just with our part 1 solution here and go ahead and do that. So day 10 part 1 solution. And then we will go ahead and copy that part 1 solution to serve as the start of our part 2 solution. Part 2.cc. Okay, let's get into it. So instead of error score, we're going to do this as completion score. Now, once again, if we do have a syntax error, now completion score for a syntax error is going to return null opt, and meaning that we're not going to consider that at all. So we'll return null opt in all the places that we previously returned an error score. Okay. Now, at the bottom here, the stack is going to determine what things we need to do in order from the top of the stack down to complete to autocomplete. And we have the table that gives us the scores there. So we'll say int completion score starts as 0, and then while parens is not empty, there's still stuff that we need to deal with there. We will say completion score. Well, so we'll multiply it by 5. And then we will add the appropriate value to completion score based on what is on top of that stack. So in the case that it is an open curly boy, then we would close it with a closed curly boy, and we would increment completion score by 1. And we're going to follow similar patterns for the other 3 valid characters that it can be here. So for square, it's going to be 2. For squiggly, it's going to be 3. And for pointy, it's going to be 4. And the default case, this should never happen because we should have never pushed anything but one of those 4 characters there, but we'll just put check fail in there as a safety check. And then, of course, no matter what, we're going to pop the top there, and then we will return the completion score. So then all that the main program needs to do is we will say we'll have a vector of completion scores here, and then we'll say so we'll say optional int completion equals completion score for that line. If not completion, if that completion doesn't have a value, then we will just skip that line and continue. Otherwise, we are going to put the actual value of that completion into the list of all the completion scores. At this point, we should check that the number of completion scores actually is odd. So, yeah. And then we can just sort and pick the middle one. So, let's get the regular sort from algorithm, thank you. Yeah. Okay. So we'll go ahead, sort completion scores dot begin to completion scores dot end, and we will read out the middle one. So size divided by 2 plus 1 will be the actual midpoint of those odd number of valid completion scores. So let's just make a build target in our build file and see what answer it gives us. This is looking very similar, just changed to our part 2 executable. And that's what it gives us for the middle completion score. Now that is I don't think these are too big that we're going to run into any like 32-bit truncation problems, but on the off chance that we do, we can change that. But let's just see what happens. Okay. Not correct. Well, once again, let's see what it does for the test input. Okay. That is one of the answers for the test input, but it's not the correct one. Let's see what scores that it is giving after these are sorted. So for we'll put a tab in front so that it's clear in the output that it's not the final thing that we're looking at. But let's go ahead and see what that does first for the test input. Okay. Oh, it shouldn't be +1 because we're counting from 0? Is that what we're dealing with here? Is this just an off by 1 error on my part? Yeah, we'll see what it does for our actual output. Okay, let's see if this one is right. Okay. It doesn't like that one either. Oh, we've got negatives, so we've got some wraparound here. Okay. Well, let's switch to using 64-bit numbers. Yeah, because we should not be seeing negatives for sure. So let's just change these ints to int64s. Let's give that another go. Oh, I'm sorry. I was on the wrong screen while I was showing that to you. But, yeah, I wanted to change these things to... Yeah, int60. Oh, and yeah, of course it has to return int64t. So basically everywhere where we had an integer, we're doing int64t instead, so that we don't wind up wrapping around. And now this should be our right answer. Definitely got to watch for that integer overflow. That is something that can certainly bite you in C++. All right, that's the correct answer. So I'm pretty satisfied with how we did today. I think that the basic approach to this problem, to use a stack of what's been opened and then, like incrementally close it so like what is legal to come next, it was definitely the right approach. The only thing that really tripped us up in part 1 was just a simple typo. Part 2 had the little off by 1 error when finding the position here, and then we had a little problem with integer overflow. Basically, we had our completion score getting larger than was possible to represent in a 32-bit integer, but when we upgraded to 64-bit integers, everything went fine. So I may take the lesson from that any time that I'm counting things or calculating up numbers in future puzzles, that I should just use 64-bit integers from the start, because this is not the first time where quite large numbers have been used in a puzzle that required that. So we'll think about that for the future. But I think overall, we did pretty well here. Let's look at personal stats. Okay, a little under 2,500 for both parts. Not bad. Not quite the best that we've done, but I'd say still pretty darn good. Um, so yeah, thank you everyone for watching. Uh, if you are watching the live stream on Twitch, remember you can check the channel profile and you'll find links to my YouTube channel and my GitHub repo there where you can find stream replays and the source code respectively. If you're watching the replays later on YouTube, just check the description down there. You'll have a link to the Twitch channel for live streams and once again to that GitHub repository for code. Thank you everyone for watching tonight. We had another fun puzzle. I hope to see you all again tomorrow night. Bye-bye, everyone.